ஆறு. Hi, David. Good morning.
JP, morning. How are you?
I'm good. How are you?
Good.
So, David, I just want to, while I'm waiting for others, I want to ask you, have you looked at this tools, open source tools for IC design, Open Road?
Yeah, so right now the design that we are doing in the chiplets that we are designing, the PhD student is using commercial tools, but we are definitely looking to switch to open source tools because we want to make this like a reproducible flow.
Sorry.
Right, we want to make our work also open source and to be reproducible by others, without having to require commercial
Sorry,
tools.
David, I couldn't understand you.
Okay, how about now? Is it any better?
Yeah, now it's better.
Okay, yeah. So, so the work we are doing, we started off with commercial tools
Okay.
because it was easier and kind of ready to go. But
Uh-huh.
we do want to migrate to Open Road and see what it can do.
I see. What do you think about Open Road? Looks like Google is doing a lot of work with Open Road. A lot of SDK, PDKs are available for Open Road from Skywater, right?
Yeah.
I saw that 130 nanometer SDK and then the Global Foundry SDK. Not SDK, PDK.
I have not used Open Road, to be honest, as a flow. So I don't feel qualified to comment overall. The only thing I know is the synthesis tool that they use. I don't think it can do automated clock gating yet.
Automated what?
Clock gating.
Clock gating. Okay.
Yeah. So as a power person, that offends me. you know,
Ah, right.
tools should be able to do automated clock gating to save power, right? Yeah. That's but again, I haven't looked at the latest release, so I may be wrong. But when I looked at it a couple of years ago, it wasn't doing clock gating.
I see. I see. Oh, you looked at a
You
couple of
had,
years. Okay.
yeah,
No,
at
I
the
came
synthesis
across
tool.
in a paper that Open Road being mentioned, and that looked interesting. They have Google is sponsoring a lot of activities with making process
Yeah, they're sponsoring
available, mainly for students.
those yeah, they're sponsoring those shuttle runs on Skywater 130.
Mhm.
Right. You use open road, but you have to make your design open source as well if you want. If you want Google to sponsor it. So they do have quite a few chips that they have taped out that are open source. So yeah, it may be worth trying and replicating. We're definitely going to look into that.
I see. Yeah, I think that's definitely be interesting to explore that from a chiplet standpoint. And for all prototyping, that may be something interesting to do and develop flows. For instance, you're thinking about
Yes.
CDX flows. That is something worth looking at that.
Yes.
And no, I think that they also support all this tickle scripting, right? The tool is actually similar to the commercial tools based on tickle scripting. Right. So any flow you develop, it should be portable to other tools as well. Other commercial.
Yeah. In theory, yep. In theory, it should be like that. I wish they weren't doing tickle scripting. Tickle scripting is I think the only place that uses tickle still is EDA companies. Some of the EDA companies.
I mean, they all migrate to Python.
We should migrate to something more reasonable, right? Tickle is the okay. This is a recorded call, so I'll stop with my bashing of tickle here. But let's just say that there is better ways to do things.
I see. I see. Hey, Jawad, good morning.
Hey, JP. Hey, David.
Is what-
Yeah, we were
So,
just discussing about the open source tools for IC design. I came across Open Road, and that sounded really interesting. So at least at basic, it does very well and supports PDK from 130 nanometer PDK. I think there is one global foundry PDK as well available as an example, and Google is sponsoring the projects.
Mhm. Yeah.
Are you familiar with Open Road, Jawad?
So, a little bit.
I see. I see.
David knows those guys in person, right? So,
Open Road developers?
some of them, yeah.
Oh, okay. Who are these guys? Is it based in the US?
I think right now Andrew Kang is driving a lot of actually not driving, but is involved with Open Road quite a bit.
Oh, the
Professor
UCLA professor?
UC
UCSD, is it?
UCSD, yes.
Oh, okay. Okay. So,
And yeah, there's actually Open Road as a whole. There's a lot of contributors, right? The synthesis engine, for example, Yosys, right? It's based off of work done by Berkeley. That underlying technology was developed by Berkeley, and I think there was a guy who put it all together. They probably use Vegalator for synthesis. They use I think that at some point they were using iVegalog for simulation as well,
I see.
like Vegalator. There's a lot of different tools in that, right? All the viewer, the DOC engine, the everything. It's all open source from different places.
I see. I see. Yeah, certainly it sounded very interesting. And something I was telling Jawad, to David, we could explore that for developing CDX flows.
Yes. I think so. Some of those guys are asking CDX to do some work for them. There's a professor named Andrew Kang, part of it, and it's kind of like a challenging thing for us to develop for others. The issue is Open Roads is a open software mindset, and we with our mission, we still maintain people's commercial interests.
I see. I see.
Our definition of open is different than their definition of open. We're more like a active industry group, right? So,
right.
so everyone can operate within their boundaries. So that may be a challenge, but anyways, I think it's a good idea to look at it and see what is it that they are developing. This morning, a idea occurred to me. Oh, by the way, JP, last week it was just me and David. Okay.
I see.
Today it's you, me, and David.
Uh-huh.
Next couple of weeks I wouldn't be here. David is going on vacation.
Oh,
So
wow.
you may be the only one calling. So, you know,
Uh,
there is
I-
something we have to think about, that we haven't really been able to get interest from folks who thought about the golden chiplet. The only interest we have so far is basically CDX and maybe developing some demonstrations along this line, right? So this morning,
Oh,
a new initiative at OCP called Open Systems for AI.
what is that?
So it's not a project, it's not a work stream, but what they have is they're saying it's a horizontal effort where people from across the OCP come together to support AI related technologies. Now, what I was thinking to pose this question for two of you here, is there something in the demo design or POC design that we can do that might be of usefulness on the AI side of things? Because I know most of the chiplets shipping out there right now are for AI, right?
Right.
At the moment, that's where the demand for large area integration is. So thought maybe we should spend a little bit of time thinking about it.
Here is a random thought. The modularity workstream is looking at chiplets, and there are some startups in there that have AI chiplets that they're eager to demonstrate. The chiplet by itself. The modularity workstream is interested to demonstrate how like basically sizing the chiplet systems for given models, right? When they use 4, when they use 8, when they use 2, and so on, right? And what kind of sizes, right? We've been beating around this golden chiplet for some time, right? Why don't we create a prototype golden chiplet virtual, right? It doesn't have to be a real, right? At the end of the day, right? Basically a virtual golden chiplet. Call it that, and allow others to work with that and see what comes out of this, right? Whether there's model issue, if there's a privacy issue, if there's assembly issue when we try to put them together, what issues come out, right? Instead of waiting for that a real physical golden chiplet shows up, we create one virtual and see what comes out of it.
Yeah, I think the idea of this virtual golden chiplet would be useful. If we develop a behavioral model, somebody can actually take that and test their chip, right? And I mean, you may know this is a verification IP, right? That all the interface standards has. This is something similar, where if you have this golden chiplet, people can come at the verified virtual package, virtual chiplet, and then they can put their own chip and then verify with our golden. design. That could be one idea. Could explore.
Yeah, right. And that will, I think might be interesting what we'll discover along the process when we're trying to define what a golden chiplet is, right? What does it need to have? What does it need to do? And right, the process of definition of that golden chiplet itself would be interesting. We'll see if there is I expect there to be privacy issues with all the models. Let's see if there's a solution to that. Right? You know, and then we can always fake out a chiplet that does what we want it to do, as long as it's simple enough, and see how that works with everybody else. If they would be willing to test against it, and if they test, do we discover anything interesting with it? You know.
Yeah, actually, with Javad, you also mentioned about that the commercial angle that we put in efforts in OCP is somewhat different from the academic, the openness. I think it's still possible because you can have a basic version of this golden chiplet available to anyone. And then if you want to have additional features or support, that's where that individual participating companies could benefit from.
I kind of like this idea. So let me explain what I understood. So what you are saying that we create all the views of a golden chiplet. And those will be mechanical views, behavioral views, electrical views, all of that, right?
Correct. Yeah, exactly. Yeah.
And then we standardize those and we say, hey, please make your chiplet like this.
No, they don't have to make a chiplet like this because we are saying this is a golden chiplet. The other party can make any chiplet of any shape, anything of their choice. As long as we have the standard bump map configuration, they should be able to talk to the golden chiplet and verify the design.
I see. So you are thinking that there will be verification views like verification IP and things of that nature.
Yeah, this is like a verification IP, except that we'll have views from different foundries participating, and like advanced package, standard package, all these are available in this platform, and people can design that chiplet and put it in the platform to verify on our design.
Okay, one more question. So remind me, what does the term golden chiplet mean in your mind with this one? I roughly know what it meant when Cash presented.
No, let me articulate what I have in mind. Yeah, right. So let's say I develop an D2D5, right? And once then I have to have a partner D2D5 so I can verify. Today, what we are doing, most people in the industry doing, is actually they're talking to their own chiplet. Right? They put two of their chiplet and then say that you are able to communicate and verify the link. But that's not really something I am good, because you cannot support third-party chiplet. A neutral third-party chiplet is what is needed where you want to talk. I identify if there are any issues in understanding of the standards implementation, right? And that's what in my definition, that this is a golden chiplet that as the industry is a neutral body created, and then that is actually a kind of reference. And if you could talk to the golden chiplet and verify your design, that means it's as good as actually that you verified on a real, let's say, plug first type of design. Right? Today, that does not exist today. And if a neutral body like OCP creates that, and I think there will be a strong adoption for it.
I'm liking this one.
And over time, people can contribute to it, add features, right? And then the service part, right? If you're making a commercial chiplet and you want the professional services, and that's where companies could contribute to it. the
That's right.
participating companies. And also, let's say you want to make the enhancement features, and that's where this participating companies can add value.
Mhm.
Right now, even the AMD, when you were presenting, they wanted to make this their chiplet. They want multiple people integrate to that chiplet.
Right.
Correct. But you don't have any simulation or verification platform before I invest a lot of money into that.
Makes sense. Okay, I'm kind of excited about this one. Okay, David, since you're the one who uh, dropped the idea.
I get the action item, right?
No, okay, well, I'm sure all of us will get action items. But what I was going to ask you is, tell me your view of what will the golden chiplet do?
So yeah, what you guys just talked about, the models and simulation, that's second and third step. First step is to define it. So I think we should go around and ask people what do they want a golden chiplet to be able to do.
So what you are saying, we go to modularity and chiplet systems and link layer and ask them that question.
Yeah. We want to define a golden chiplet, what we want it to do.
Correct. Yeah.
Right. A virtual golden chiplet, right? Let's define it and let's see what do they want it to do and what issues they're concerned about. Privacy, competitive pressures, things like that, right?
Yeah, good idea, David. Yeah. We can come with a strong definition for it. Pi layer, link layer, and how it is. And today, one of the challenges is also that software bring up. So this is a problem that we were addressing, Jawad, in the POC. There is no
Right.
software development vehicle available, right? And for chiplets, and if you have this open platform available, people can start developing software using the golden chiplet, and then verify. It becomes like over time. I see a good trajectory of growth path for this.
Oh yeah, I'm liking this thing. So I think, and I actually like your suggestion, David, that we should go visit some of these work streams and socialize this idea, right? So I think what JP, we should make few slides,
Sure.
kind of like laser focused on getting these work stream to give us some critique and some constructive input. And I really think we should go visit modularity, chiplet systems, link layer. And I'm sure we can visit BOW and business, but I think, higher level than just the electrical PHY is probably going to be a lot more interest for verification IPs, right? So I'd say if we can create a messaging around it with some what are we thinking, and solicit some ideas from various people.
Correct. Exactly.
Right. That way our membership here might grow as well in a more organic manner. Right.
Yeah, I can actually put together a kind of starter slides next week when we meet, and can review that and enhance it.
Yeah. David, will you be able to attend next week?
No, not next week. No, sorry.
Okay.
So
No, I
JP,
can calculate that.
I don't know. There is a possibility I may be able to attend, but at least what you should do is circulate it by email to me and David.
Yeah, absolutely.
Yeah.
Yeah, we can get started next week, so we can circulate.
And maybe even Anu, right? So, because I think she will be pretty excited about this as well.
Right. Yeah. Yeah. So let me take a
We
look
might
at it.
we might be able to get virtual triplets created by universities, right? If it comes to that.
Yeah, so David, once JP sends the slides, please start adding some of these ideas, because if we can create a program like this,
Yeah.
we know a lot of universities are very carefully looking at what the hell are we doing, right?
Yes. Yep.
Yeah, I mean, using this, the CDX flow can also be embedded in this, right? It's a part of it. Because anyway, you have to create a golden chiplet, and chiplet creation automation comes with the CDX. So a lot of things can be folded under this umbrella.
Yeah.
And also, Java, that you mentioned about the open systems for AI. Is it with the 8 a.m. meeting today, ODSA meeting, or is it a different meeting?
No, it's a different meeting, JP, and this initiative is going to become big. The reason is every project in OCP, server and immersion and all of those guys, everybody's main driving factor at the moment is AI. Right?
I see.
So OCP decided that they're not going to create a new project. Instead, what they will do is they will create coordination workshops and meetings and project and activity. So because it's a huge organization, OCP, right? It's like I don't know who's doing what. I mean, I barely know what's happening in server project, anything in the rack or data center or cooling or power delivery or any of that. I have no idea, right? So they do want to coordinate chiplets with the rest of the things as well. So we are on their list of technologies that need to be coordinated, right? They do have a workshop coming up on June 23rd, where Anu is going to try to find something where, we take some of our work streams there and, tell that to other projects in hopes of coordination. But there'll be a lot more activity coming down this line,
I see.
given how the market is demanding. So that is the background of this initiative. And the initiative is being led by Greg Salmon. And I think Cliff is pretty deeply involved in setting things.
Oh, Cliff is it? Okay. Who is Greg Salmon?
I think Greg is from AMD, right, David? David.
I don't know actually.
Yeah.
Oh, Greg Salmon. Yeah, I see in his name, in AMD. Yeah.
Yeah.
He's driving this, is it? That what is the end goal for this? They'll come up with the specs like OAI, or what is the end goal?
Oh, I don't think we know the end goal, JP. This is one of those things, right, where future is unclear and a bunch of smart people work together to define what it should look like. Right. So we know the problems. Everybody knows the problem. The biggest problem is efficiency of compute and communication, right?
Right.
For data centers, how to supply all the power, how to take all the heat. Now they're talking about 800-volt DC going directly to the board. We are having hard time designing with the 60-volt or 50-volt, right? Still, all the product in the market is like 12-volt, right? But when you're talking about like gigawatt of a rack, you have to solve those issues, right? So those are the kind of problems they got that they want solutions for, and it's not just one group who's gonna come up with solutions. So I'm sure everybody's big question is, how can you pump a lot of power and get a lot of work done by these machines and make like gigantic data centers? Nobody knows at this point. Okay, JP dropped off.
Yeah, I'm on my last 2% on my phone. So
Yeah.
if you see me go, that means I'm out of phone. Yeah, maybe he'll regain. I've been having connectivity issues as well. So let's see.
Yeah. David, I like the idea. I think you should work a little bit with JP to put together some slides and socialize it.
Yeah, I think it makes sense. It makes sense to go around, even talk to Gu and the business Workstream, because they came up with, in a way with the idea about the prototyping platform. Cash also had ideas about building chiplets.
Yeah.
And we need to solve them somewhere.
Yeah.
Go
Okay.
for
So, okay, then maybe we'll either talk via email or because JP seems to be not back. So,
Yeah, okay, yeah, so sounds good. Yeah, definitely. As soon as JP sends out some sites, we'll review, update, and we can communicate over email.
okay, sounds good. Take care.
All right, do it. Bye.
Bye.